So I'm Smita. I work as Senior Solutions Architect with AWS ISV segment. And today, while I'll be giving you a brief about the Amazon's AI ML capabilities, I would also like to share some insights into how we have transformed the journeys, the Gen AI ML journeys for the customers into a success story. And then we'll have Nishchay Shah, who is a global CTO and EVP, Cactus Communication, present the story to you. And they just received the award, the AI Conclave India Award for the same as well. So round of applause for them. Thank you. Will be rising if you follow this approach. With this, I'll hand it over to Nishchay to give us a glimpse into the enticing journey of Cactus Communication on generative AI front. Over to you, Nishchay.
So I had prepared about 5 jokes, but since Smita took 70% more time than allotted, I'm going to straight jump into the presentation. I'm Nishchay, and I represent Cactus. Cactus is a sci-tech company, and we work with researchers and the stakeholders to improve how research gets funded, published, communicated, and discovered. Cactus started about 23 years ago as Editage, as one of the service business, and then we've added products like PaperPal, Discovery, and Mind the Graph. So let me talk about 2024. So in 2024, we processed 20 billion tokens. Our research database grew to 250 million artifacts. We processed 1 million natural language user queries, and we served 1.5 million researchers and students. All of this under the product called PaperPal. PaperPal is an ecosystem of tools that is designed to empower researchers and academics. It helps authors write, edit, refine their manuscript for publication. PaperPal also has research discovery tools, literature search tools that help researchers make sure that they are, their research is in compliance with the technical requirements. PaperPal was overnight success, which took us 4 years to reach. The first couple years in PaperPal, there was no PaperPal. The first couple years, we were in 18 years in the business, and we had amassed a lot of intelligence. A lot of intelligence about how to do business, a lot of intelligence about how our industry works, how research works. So our first goal was to create solution to help our editors, our reviewers get efficient. And when we started, it was very difficult. 4 years ago, although it seems only 4 years, the AI knowledge was still limited. We were figuring out how to get started. So the first couple years was a lot of failures, a lot of experimentation, a lot of cross-validation, working with the teams in-house, working with the editors. Around in the year 3, we finally reached, after 50 different iterations, we finally released our first generation tool into the ecosystem, and we saw that it is starting to benefit. After multiple iterations there, we finally saw that our product, our machine learning solution is good enough, such that we are actually making production impact, which means we are actually moving the needle of the business. We were actually hitting, saving money in the bottom line. While that was happening, we realized the product, we've created something great, right? We've created something big. And at the same time, we were hearing from our customers that there's a need for a DIY tool which does all this. So while we have a services business, there was a need that was identified. So these two things almost came together, and that's how PaperPal was born. And today, PaperPal, we are in the 10th generation of our models. And PaperPal is a combination of managed LLMs, proprietary LLMs, a lot of business logic, a lot of manual Markov chains written, and and obviously, in order to build PaperPal, what was needed was machines. There is massive amount of machine learning that goes in it. When we started, obviously, it was newer. Hardware was difficult to procure, expensive. So we started with simpler decision systems. We started with Bayesian systems. Then we moved to, when we started using CNN, then we started using sequence-to-sequence. Then attention came in. After attention, we moved to pre-trained transformers. And finally, over the last year, we cascaded into generative AI. So today's version of the tool that we have is a combination of everything that goes in. So under the hood, it's not just Gen AI. It's Gen AI plus 50 other things. And at every step of the way, we had Amazon by our side as our partner in scale. In the earlier days, we were doing a lot of work directly on the EC2 instances. We spent a lot of time there. Then we moved into a mature machine ecosystem, and that's where SageMaker came to the rescue. After SageMaker, we were the first partners to start using Trainium, and that didn't go really well because it was very early days and there was learning on both sides. We understood what was to be done, and so did Amazon. And then finally, Bedrock came into picture, and we deployed a lot of our solutions on Bedrock. So over the last 6 months to 8 months, we are starting to, we've started deploying things on Bedrock. And we've seen clear benefits immediately, almost immediately. So during the period where, between SageMaker and Bedrock, we were hosting a lot of the infrastructure in-house. In-house means on EC2, but we're managing ourselves. So we had to over-provision. The DevOps team was constantly under pressure to make sure that not a single customer faces challenge. So there was a lot of over-provisioning. Scaling GPUs were also very hard. Procuring, making sure that distribution happens. Updating models, local training, all of that also became a challenge. And finally, we were spending a lot on fixed cost, which our CFO did not like. I don't know if some of you have CFOs. I'm sure you have. This is the big problem there. And when we moved to Bedrock, we saw that almost immediately a lot of challenges were starting to get resolved. Our quota planning became simpler. Upgrading models, cascading models, multiple models together, that became much simpler. And finally, we were in a pay-as-you-go model, so there was not initial shock of the cost. Elasticity, although is starting to get solved, there is still a lot of work to do both on Amazon side and our side. And we had a very nice discussion with an Amazon product head for Bedrock yesterday, long discussion, and there is a lot of next steps coming up. I don't know if I can reveal a lot of things, but a lot of fun things coming up in Bedrock too, which we are really excited about. So far what you've heard is that we are in the business of research. So it made a lot of sense for us to build academic database. So what we did is we have built the world's largest, cleanest, most accurate, most recent academic database. And that is built with the data coming in from publishers, data coming in from archives, data coming in from repositories like Crossref, JStage, PubMed. We've got publishers like BMJ, Springer, Sage, and more. Now, with all this data coming together and creating a nice data lake, data ecosystem, what we built is, on top of that, we built a product called RDiscovery. RDiscovery is a tool, which is a research discovery is a tool that helps researchers find research that matters to them fast. Now, the keyword here is matters, right? With so much research being published every day, what matters to a certain individual, even though they're in the same field of research, will be very different from a different individual. So we do a lot of personalization, again, using a lot of Amazon services. We use a lot of fingerprinting of the user and the data to do a nice matching between what does the researcher want to read. I'll wait 10 seconds while all of you download Research Discovery on App Store. No, I'm just kidding. In our discovery, while there is a lot of machine learning still there, the primary challenge was data. Managing data at scale of 200 million plus artifacts, which each artifact having 50 different attributes, was a very different engineering challenge. On top of that, what we saw is that publishers, we were assuming that if the data comes from publisher, it's going to be clean. If the data comes from repositories, it's going to be clean. Plug and play, pay as you go. Plug and play, sorry. But that was not the case. We saw that the data is a mess. Research data is a mess. And we had to spend a lot of effort in cleaning up the data, transforming data, deduplicating, and disambiguating. A lot of technology was used there. And then once all of that was done, pushing it into a queryable cluster, starting with Elasticsearch. And then finally, the app was born. And again, as seen before, AWS to the rescue. before Redshift happened, when we were small, we started using Neptune. I don't know if Amazon Neptune still exists, yeah. So we were one of the first ones to kill Neptune, like destroy it. And there's a long story. If anyone's interested, I can probably chat for half an hour or more. We started using Neptune, and we started loading data because we were in a good conversation with Amazon. We got almost infinite limits. And once that happens, Neptune just could not process. So we got connected with the Seattle team. We worked a lot with them. They were working nights and weekends for us to make sure the Neptune ecosystem works. But it didn't. It failed. So then we realized that we are choosing a wrong tool for the job. We cannot graph this whole 200 plus million into 50 into whatever. So that's when we started using Redshift. And Redshift helped us really well. At least for the first few million rows, it was very easy to get things in, look at the data, run iterations on the data, clean up, transform, load, multiple times. But then that hit scale. That hit scale not in terms of engineering, but in terms of cost. Because we realized that as we started loading tens of millions of rows, we were doing full table scans. And that ended up being very expensive for us. So Redshift was like a cruise. It could haul, it could displace. The displacement was very easy, but it took a lot of fuel. So we wanted to do the same thing, but with less cost. And that's when Athena came in. So we started using S3, Athena over S3, and loaded data into Athena. And we did a lot of work on smart partitioning. And after those smart partitioning, what we could do is we could select certain partition to check the data, run iterations on it, and stop. So we went from spending thousands of dollars per week to probably few tens of dollars just for checking few things. After all that was done, then the biggest challenge was to load everything, all 250 into 50, into an ecosystem which can be queried on. And that's when Elasticsearch came in. We tried to do things on our own, but then DevOps is like, you got to use managed service. We moved to Amazon's OpenSearch. And then on top of that, then we have added Bedrock and more. In the beginning, I spoke about natural language user questions. So after our discovery became super famous, the next logical step for us was to, what do we give users even more? How do we support users more? How do we give them which they want, what they want? And the natural progression for us was to give them open natural language queries. So users could put in a natural language query, and what we did is we took the natural language query, we did intent expansion. After intent expansion, we figured out, the first step, which is the Bedrock step, the intent expansion went into a machine model. Machine model gave us back concepts and key phrases, a large, massive list. That then went to Elasticsearch, and within Elasticsearch also we've got some machine models running. And then Elasticsearch gave us back, again, a large list of documents that are relevant to the user intent. Once those documents we then sent it back to our proprietary re-ranking system, which takes 300, 400 research papers and ranks it based on various parameters. After those ranking, it will go back. It will take those 300, rank it. We take the top few, 30, 40, depends on the context, and then we send it back to our machine system, which will then take all the data, summarize it, create listicles and whatnot, and send it back to user. And what also we did is that we realized that we have users from literally all the countries in the world, countries that I've never heard the name of until I looked at our data and was like, wait, there is a country like this? That's amazing. And we realized that research is, when we think research, we think English, but research is not just English. There is a lot of languages. So what we did is we added support for multiple languages. And this is an example of an Indian language where you can ask a question, it does all of these things and gives you the answer. Now, we did this 2 years ago. The infrastructure, the system works, no one's touching it. And then everyone started talking about RAG. And they were like, you know what? We did RAG before became mainstream. So yeah. So 2025, what are we looking for? What are we looking forward to is agents. What we've realized is that when it comes to a user asking a question, when it comes to a user clicking on a button, we feel that we understand the intent of the user, but after interviews, after looking at user feedback, we realize that intent is much wider. Sometimes the user also doesn't know what the user wants. They don't know what they want. But we are now working with Amazon again on Bedrock. The DevOps team is hard at work to create cascading agents where a query comes in from our product. That query gets expanded and distributed to, say, 10 different agents. 10 different agents doing 10 different work, gets back and then sends data back to the user. Now, when I say sends data back to the user, that is not just text data. The data can also be action. So that's what we are doing. And the last thing that I want to end with is that, this is the era of generative AI. Everyone's talking about it. And while we should romanticize Gen AI, it is a flavor of the season. It is very important that everyone understands that data is very important. Really good data practices are very important. Some of the use cases you may be able to resolve directly using a public LLM or a proprietary LLM, and that will probably take you to 95%, which may be good enough for many. But when you're running production workflows, when you're building products that actually makes money, not just burn money, you need to provide, in this era, you'll have to provide user more than what, say, a ChatGPT can do or a Claude can do. And that's where your data comes in. That's where your proprietary data comes in. That's where your personalization data comes in. That's where your public user data comes in, right? So if I'm a researcher who's new, and I don't know how to ask, what to ask. But if you already have 50,000 researchers like me already asking this, we can tell the researcher, listen, I know what you want before you tell me. That is an add-on, right? That's a differentiating factor. So and that is our example. Everyone would have different examples. So it is important that as we innovate, as all of you innovate in Gen AI, please do not forget to prioritize in your businesses, in your teams, in your DevOps team, BI team, strong data governance, strong data quality, and integrity. Data, it is the unsung hero behind every successful Gen AI implementation. And that's my time. Thank you very much.